In today's class, we'll discuss artificial intelligence. Basically, AI refers to development of computer systems that can perform typically tasks that is supposed quite complex. So it requires human intelligence such as learning, problem solving ability, decision making capability, perception, and reasoning. Okay, so AI consists of it involves different types of algorithms and models that enables machine to process the data. So you can identify the patterns, you can make the decisions by minimizing the human interventions. So these systems is designed in such a way that this can be improving the overall performance of entire uh, industry or entire particular machines. Okay, so we have different types of uh, networks, AI networks. So first is a narrow AI, that is weak AI. This is a specialized system designed for specific tasks such as image recognitions or language translations. Most current AI applications for this narrow AI is Siri or Alexa, or recommendation systems such as Netflix, Amazon. Then second, we have general AI, which is strong AI. Again, it is a hypothetical AI with human-like intelligence. It can capable of performing intelligible tasks that human can perform. This level of AI, that means strong AI, we can say we are creating the systems in a such a way that whatever decisions are normal human would not cannot take, that can be taken based on the this algorithms. Okay, then we have super intelligent AI. That is a theoretical feature AI, surpassing the human intelligence across all the domains. This remains speculative and it's subject to philosophical and ethical debate. Okay, now look at the part. So how these systems is integrated. So we have machine learning, deep learning, then we have natural language processing, computer vision, robotics, and expert system. Okay, so these are the different key technologies that are included in AI. So we look at the machine learning part. It is a subset of AI where algorithms uh, patterns from learn patterns from data. It can be predicted some decisions or it can take some decisions. It is supervised learning, unsupervised learning, and reinforcement learning. That are the common paradigms you can say in machine learning. Similarly, for deep learning, it is a subset of machine learning. So it uses neural network with multiple layers to process a complex data such as image, audio, or text. Then we have NLP, natural language processing. It enables machine to understand a generate human language that is used in chatbots, translations, and sentiment analysis. Then computer vision. It allows machine to interpret visual data such as images, videos, or object detection or facial recognition. And then robotics. Now it is a combined AI with physical system that can automate tasks in a dynamic environment. And we have expert system, that is rule-based system that with the human expertise in specific domains such as medical diagnosis or financial forecasting. So what are the different challenges are associated with this AI? That is important. But in initial implementation cost, that is more high initial cost if they are implementing AI requires significant investment in software, hardware, and training. Then again, second issue related to data quality and availability. So AI relies on large, high quality data set, which may not always be available. Then workforce transition. Workers need reskilling to operate and collaborate with AI system, and ethical and security concern. Again, AI system must be designed to avoid bias or ensure data privacy and can protect again from the cyber threats. Now look at the flow, how this AI will get implemented at various manufacturing industries. So basically, if you look at the structure, so AI is useful for root cause analysis. Then it can be written and positions of detector. It can be used for data transmission. Then it can use a machine learning algorithm, production tools that can be linked with AI. Then we have some decision making ability with this data analysis part. Then we have automotive repairment, that is preventive maintenance purpose we can use. So we can reduce the machine downtime, and expected benefits means we can increase the overall performance or efficiency of that particular equipment or any industry. Now, these process automations and problem identifications are there. So basically, this system is taking historical data of that particular industry, and based on that, it is doing some kind of root cause analysis. Okay, and then that informations will get passed on to all the concerned members, like we have discussed this part in stream analytics or data analysis part, where the data will get generated from that existing machines, and then based on analysis that data will get circulated among all the concerned people so that industry can take decision whether the total flow is okay or not. Okay. Then we have second part, how that data will get generated. It can be that data can be taken from sensors. Okay. So sensors are taking that data and then that data will get stored on cloud, and then we are using some machine algorithms or neural networks NLP for analyzing that particular data. Okay. Now, after analyzing all these parts, people are concerning about the overall their targets, like how we can link this AI engine with production line, or how we can link this AI with process line. That is important part. Now, suppose say if there is any failure in between the operation, then that also be detected by that sensor, because different sensors are mounted on that machine, so that alarm will get, that signal will get passed on to the concerned people or concerned technician person, so that the prompt action of we can take on against the failure. Then we can reduce the mission downtime. That is again one more facility is there. Okay, so this is the overall benefit of implementing AI. So, the next part is we have this different integrations of machines. Okay, so look at the software plan, which includes how that sensors are mounted on various machines and how we can take the data at each and every systems. Okay, now just look at the part. So let's say this is the routine flow of operations where the product will come at station one, from station one to station two, then station three, station four, and then finally it will get assembled. So this is the integrated flow where manual interventions and robots are implemented to design or develop that particular product. Now, how that system is getting that data? Suppose say if some machines require maintenance, then it will get identify that particular pattern with the help of sensors, and then that signal will get sent to concept of person. Second part is there. Suppose say if you want to optimize the flow, again, root flow can be optimized based on the your manufacturing flow or process flow. That is again one more advantage there. Okay. Now there are some virtual agents are also available to provide information to the operator. Okay. Then we have each automated guided vehicles are there. Okay, that can carry parts, or it can detect the obstacle, it can move the parts from one station to other station. Okay. Then if we have generative design principle, then we have robots for image recognitions that can automatically adapt the changing locations of parts. Okay. And then with the help of AI, we can detect the quality through image recognition. So just look at the from all these processes from station one to station three. This entire system, or we can say smart factories, deal with or uh, connected with all the AI networks, so that your final products will pass through all the stations and you get accurate or exact product for the design. So this is the advantage why we are implementing this uh, AI technique at various industries. Okay. But the major concern is whenever we are implementing this part, suppose if you are facing any quality issue. Okay. So we should ensure that whatever process data is there or standard data is there, that data should be appropriate put it into that system. Then and then that AI pattern will make the recognitions related to that data. Suppose if you are targeting some kind of surface image or some values of accuracy or precision, then desired value should be there into the systems. Then and then you can get that inspection report or detailed report of that particular machine as per the standard. Okay. So this is the overall. And then lastly, same for purpose. Suppose if it can detect the future demand like product. Suppose I want to supply this product with the help of the same network. Then and then we can connect this part to final station, and all this material flow related to delivery of that product will also get connected to that particular system. Okay. So this is the overall advantages, how we can implement this AI part, what is the overall flow, how these machines are integrated to each other, and what kind of data we can collect by implementing this AI through all this entire network. Okay. This is all about introduction of AI, different parts, different networks which are available, what type of data we can collect, and what are the different challenges of AI are there in implementing that AI in industry. Okay, so we'll stop in the next class. We'll start with applications of AI.